So if you look at this diagram here, we are asked to find angle QPR and also angle TOP. So here in triangle QOR, the base angle are equal. Why? Because it's an isosceles triangle. Why did I say it's isosceles triangle? QO is equals to OR. That's the size. QO is the same thing as size OR. So if you have a triangle with two same size, therefore the base angles are equal. So that's what I wrote here, base angles of isosceles triangle. So now, also in this same triangle QOR, if you add up all the angles, it will have 180, sum of angle in the triangle. So 32, which is this side, plus this side 32, plus O plus QOR plus QOR equals to 180. What's the reason? Sum of angles in a triangle. Sum of angles in a triangle. So now I can know the value of my QOR. My QOR will be equals to 180 minus 64. 180 minus 64. So 180 minus 64 will give you 116 degree. That's QOR angle at O equals to 116 degree. Now also if you look at a QR sustains two angles, one here at the center and one here at the circumference. That's the one we're asked to calculate for. So we can simply say the angle subtended by an arc at the circumference, the angle subtended by an arc at the center is twice the angle subtended by that same arc at the circumference. Look at this arc running from here to here. Now from here, go to the center, to the end, to the center, and also from here to circumference, from here to circumference. So this one at the center is bigger than this one at the circumference. So we already know the one at center as 116. So we can say QOR equals to 2 QPR. What's the reason? Angle subtended at the center is twice the angle at circumference. So if that's the case, you can simply say we can simply say 116 equals to 2 QPR by 2 by 2. So this cancels this, this here cancels this. So QPR, if you divide 116 by 2, you have 58 degree. So that's for the first question. Then for the second question, the angle says, the question says we should calculate for TQO. Now TQO is not subtending an angle, so we draw an imaginary line to show the angle. Draw an imaginary line to show the angle. So this is the angle we are calculating for. That's from here to here. Now we already know this side to be 58, And if you look at TPRQ, you see that it's a quadrilateral in a circle, so it's a cyclic quadrilateral. And what's the rule or theorem of cyclic quadrilateral? It states that opposite angles of cyclic quadrilateral are supplementary, meaning if you add them up, it will give you 180. So we can simply say this angle here, that's 15, plus this angle 58, plus this angle 32, plus this angle we are about to calculate now is equals to 180. So we can simply say angle TPR, angle at P, plus angle TQ, angle at QR, is equals to 180. What's the reason? Opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. So now, what are the opposite angles? So TPR is 15 and 58. So we say 15 degree plus 58 degree plus this angle here TQR 32 degree plus the one we are looking for TQO equals to 180. We've already stated the theorem, so we can simply say TQO equals to 180 minus 15 minus 58 minus 32. So TQO equals to 75 degrees. Please don't forget to follow my channel, subscribe, like, comment, and also ask questions if you have any question to ask. Thank you for watching. Have a nice day.